Let us see how we can configure high availability for HDFS Namenode. It can be done using shared edits or journal nodes. However, using Cloudera Manager, only journal nodes is supported. And shared edits is a bit legacy and a bit outdated. And hence, we should consider configuring HDFS Namenode high availability using journal nodes. That being said, make sure Zookeeper is installed and running along with HDFS components such as Namenode, secondary Namenode, data nodes, etc. If you actually go to the Cloudera Manager web UI, you can see that both HDFS as well as Zookeeper are running without any issues. Now, you can actually run this command to understand what is being configured to Zookeeper till this point. This way, we'll be able to understand what is going on whenever these changes are made at Zookeeper level. So this zkcli.sh command will actually take you to Zookeeper command line interface, and here you can actually say ls and root file system or root to Znode, and you can see there is only Zookeeper till now, and there are some subdirectories within this. You don't need to get into all those details. Once we actually set up high availability, we'll come back and see what is going on here. Let me come out of this by saying quit, and then we'll actually go ahead and configure high availability for HDFS using Cloudera Manager. Here I am in the Cloudera Manager. Let me click on this HDFS and go to instances and review the current status of HDFS cluster. We have 7 nodes in the cluster. One is designated as a gateway node, and also we have configured Cloudera management service in it. However, out of the remaining 6, we are using 5 of them for HDFS. So 2 of them are running Namenode and secondary Namenode, and they are called as masters. They are nothing but Big Data Server 2 and Big Data Server 3. And then Big Data Server 5, 6 and 7 have data nodes on them. They are designated as workers. Also, we have configured gateway on all the servers. There is a reason behind it why we have configured gateway on all the servers, even though we are actually running the commands only from Big Data Server 1. The reason is Woozy, and you will understand the details when we actually configure Woozy on our cluster. You can configure high availability for HDFS by expanding these actions and clicking on this enable high availability. If it is not managed by Cloudera or any other distribution, you can actually configure high availability from command line also, but it is a bit tedious process. When we have management tools, we should only use management tools to configure high availability. You can give the name of your name service. What is name service? We'll actually get into those details when we discuss about the key concepts with respect to high availability. For now, you just give whatever name you want. I'll be leaving the default name, which is nothing but name service 1, and then I'll click on continue. Here you can choose the Namenode hosts. It already chosen Big Data Server 2 where the Namenode is currently running, and it is facilitating us to select the other host. There has to be 2 hosts to configure high availability. So here I am expanding this and I am choosing Big Data Server 3 as the second host. Already on this host, secondary Namenode is running when we actually configure HDFS using typical process. Now you can click on OK. And then we have to configure journal nodes. It has to be in odd number. We will be configuring Big Data Server 2, 3 and 4 as journal node hosts, and we will see the concept behind it at a later point in time. So choose Big Data Server 2, 3 as well as 4 here, and then click on OK, then click on continue. Now you can review the changes. This is the Namenode data directories, data1 DFS NN on Big Data Server 2 as well as Big Data Server 3. However, when it comes to journal node edits directory, it will not fill the values with defaults. We just have to enter those values for each and every server on which journal node is running. So here we'll be using this notation, data1 JN, or you can actually say data1 DFS JN also. It's up to you. So we are using the data1 as mount point, and it will create a subdirectory JN, and it will actually place files here which acts as journal logs. We will talk about those at a later point in time. So I'm using the same path on all the 3 servers. Now there are some extra options. If you want to disable these things, you can disable, but you can leave these defaults as is. One is force initialize the Zookeeper Znode for auto failover. Any previous Znode used for this name service will be overwritten. So if you already have a high availability and if you are reconfiguring for whatever reason, it will actually force initialize the Zookeeper Znode for auto failover. However, we don't have anything, so whether you enable this or not, it doesn't make any difference. Also, again, if you want to reconfigure with high availability, you have to enable this, clear any existing data present in name directories of standby node. However, we started afresh, so we don't need to worry about this. This is also related to that only. So whether you choose these things or deselect these things, it doesn't make any difference. Then you can click on continue, and now it is actually enabling the high availability for the HDFS, and it will actually run series of commands. You need to focus on this and understand what is going on. First, it is checking that name directories for the new standby name node either do not exist or are writable and empty. It can optionally clear directories if we actually choose in the previous step. And then the second step is check that edits directories for the name service either do not exist or are writable and empty, can optionally clear directories. So this is for standby and this is for the name service. Then it is stopping the HDFS because we have to disable and delete secondary name node, and hence it has to stop HDFS. When it stops the HDFS, everything that is dependent on HDFS will also be stopped. You can actually review if you want by clicking on Cloudera Manager dashboard and see everything is stopped. However, they will be started immediately. If it is delayed, you will not be able to see any service being stopped. Then it will create roles to enable high availability. It will delete the secondary name node role. The checkpoint directories of the secondary name node will not be deleted. Configuring name nodes and the HDFS service to enable high availability. Now it will actually configure active name node and passive name node. There will be only one node which will be active when we actually configure HDFS high availability or name node high availability. Now it is initializing high availability state in Zookeeper. Now if you go back to this command prompt, and if you actually run zkcli.sh command and see the details, you will see additional Z nodes here. So I'm running ls/command here. You can see it has added another Z node which is Hadoop-HA. Now you can go back here and start exploring what is happening under the hood. Once the high availability state is initialized in Zookeeper, it will start the journal nodes, and we'll come back to what is this journal node at a later point in time. Then it will try to format the name directories. If they're empty, it will format, but we already have the data because we started this as a typical Hadoop cluster, and hence it will fail. It is fine if it fails to format name node. Actually, it should not format the name node. Now it will initialize shared edits directory of name nodes. Then it will start the name node that will be transitioned to active mode. So one of the name node will become active here. Now it will wait until the active name node is started. Then it will actually bootstrap the standby name node by initializing its name directories. And then it will actually start the standby name node. Then it will actually start something called failover controller. So we need to understand what is this failover controller also. And then it will actually start standby name node. Then it will create the temp directory if it is already not created, but we already have it, so it will not act on that at all. Then it will actually start all the dependent services on HDFS after starting the data nodes and other components that are related to HDFS. After starting all the services, it will also deploy the configurations file for clients of services in the cluster. That being said, there are a bunch of new words which you are seeing here. One is active name nodes, standby name node, then the journal nodes, then shared edits, then failover controller, and you should be able to understand all this information. We will actually cover those things as we proceed and explore the key concepts behind the high availability configuration. So as I have mentioned to you earlier, you can configure your name node high availability either with shared edits or journal nodes. So even with journal nodes, there is something called shared edits under the hood. However, with the journal nodes take the onus of managing the shared edits, and we'll understand how it actually manages. That being said, we can also configure name node high availability without journal nodes, with only shared edits, and then it is a bit less reliable. Journal nodes brings that additional reliability to support this high availability. That being said, now let us go to the Cloudera Manager and click on continue. It says successfully enabled high availability. You can click on finish. There are 2 name nodes and also there are 3 journal nodes and then failover controllers, so on and so forth. In case if you do not see these values, make sure you either refresh this page or go back to the Cloudera Manager and click on HDFS service, and then you should be able to see all these details. We will get into the actual concepts behind this journal node, failover controller, etc. as part of the next topic. Now if you click on this name node and go to instances, it will filter for our name nodes. there is one active name node and one standby name node. Earlier with typical configuration, you should be seeing name node and secondary name node. And with typical configuration, if you stop the name node, nothing will happen except for name node is being stopped. When the name node is stopped, everything come to an halt. With active passive configuration, if I stop the active name node by selecting that and then clicking on stop from here, automatically the standby name node will become active. Just it will take a moment, and then the name node which is running on Big Data Server 3 will become automatically active for you, and it will be business as usual for the projects that are running on the cluster. Still it is in standby mode. Now you can see that the name node which was running as standby on Big Data Server 3 have become active, and the name node on Big Data Server 2 is in stopped state. Now if you think about a typical configuration, if the name node goes down, everything will be at halt, and if you have to bring some other node as name node, we have to restore FS image, recover edit logs, and also we need to update the IP addresses on all the worker nodes where data nodes or other services are running, and then only your cluster will be up and running as business as usual. Otherwise, your cluster is not available for the projects. That being said, with active passive configuration, it is taking care of all those things automatically, and it just took around 15 to 20 seconds to bring this standby name node as active name node. Irrespective of the size of the cluster and amount of data we have in the cluster, which means the size of the name node metadata, this switch will happen within few seconds. It will not take minutes or hours like it is with respect to the typical configuration of the cluster, in case if you have to fail over to some other node as name node. Very, very important concept when it comes to managing the larger cluster. When we have so many projects that are running, and if they are mission critical, you have to make sure that you have high availability configured, and also you should be able to troubleshoot and fix if there are any issues. Now it is time for us to get into the key concepts with respect to name node high availability. However, before getting into that, let us make sure the other name node is also up and running. It will become standby automatically. It will just take a moment, and then Big Data Server 3 will be active name node, and Big Data Server 2 will be the standby name node for our cluster.